Hi everyone, my name is Danielle Rothschild Doyle. I am a current second year in the Cognitive Psychology program, and today I'm going to be talking to you about applications of spatial thinking. But first, you may ask, what is spatial thinking? Spatial thinking is you're using spatial thinking when you pack your car to go on a trip, with your groceries, when you pack your suitcase, or even when you made too much food and you need the right size Tupperware for your leftovers. Spatial thinking is also applicable in a variety of different ways because it is related to STEM and medical thinking, such that higher spatial ability is related to higher ability and skill level in these fields such as STEM and medicine. And this means that we research a lot how experts in these fields think spatially and what that means for everyone. Thus, there's all of this research that we look at how people think in these fields and spaces and have questions about how spatial ability is learned or how these fields are learned, and questions on if the information that is learned in each individual field and how it may be specified can be transferred across these fields. These questions of knowledge transfer have been around for over 100 years, and there's been a lot of decision making on what people think is either knowledge can be transferred or cannot be. And more recent research has shown that the transfer of knowledge is somewhat dependent on the application and field to which this is going to be applied. So we return to the question of spatial thinking and transfer in the field of STEM and medicine. Decades of research have shown that there are in-depth investigations of spatial skills in particular fields and shown that this type of knowledge can be specified to each field. For example, chemists often use 2D symbols to understand 3D molecules, or surgeons learn through 2D models and 3D models to be applied to how they actually do surgery on the human body. Another example is for geologists understanding fault lines in maps and land masses. So researchers looked and see if this knowledge on how they can read maps could be transferred to the reading of words. So as you see here, there are 3 different groupings of words. The first one is faulted, so the words are transformed similarly to how fault lines transform land masses. The second is randomly displaced, where the words are shifted in a way that is not typical to how words are faulted, to how land masses are faulted. And the third is exploded, which is transformed in a completely different way where it takes up a lot more space. Okay, so all 3 of these words are the same word, transformed differently. I'm going to give you a couple seconds to see if you can figure out what the letter grouping here might be. So this letter grouping is RPEPD. It is the word red with P's interspersed. And if you couldn't figure that out, neither could I. Also, neither could chemists, who were performing just as well as geologists on the regular basic spatial skills, but the geologists were able to identify the word in all 3 of these conditions, and not just where it was predicted in the words that were faulted. This suggests that they were able to take a skill that was trained on learning how to read fault lines in land masses to not only faulted words, but also different types of similar word transformations. This suggests that this knowledge could be transferable, and other research has shown similar findings. So when we were asked to investigate this potential relationship between spatial ability and knowledge in the field of prosthetics and orthotics, we were extremely interested in, because this field focuses on the design, fabrication, and fitting of prosthetic limbs and orthotic devices, which requires that you have a good understanding of the human body, but also of art and engineering and a variety of other STEM fields. So our current project is to explore how these fields relate to each other and how spatial ability may play a role in the creation of prosthetic devices and orthotic devices, such that we can better train students in a master's program at the Northwestern University Prosthetics and Orthotics Center at the Feinberg School of Medicine downtown in Chicago. So in order to ask this question, we have to talk about what we can measure to actually understand this. So right now, we are currently investigating how students' spatial ability transforms throughout the program to see if we can identify which particular skills are relevant for this field. And right now, we are doing this with basic spatial skills so that we can identify more complex spatial skills at a later time. The first measure that we are giving is a measure of mental rotation. This is one of the most common measures of spatial cognition that have done. If you have ever taken a spatial assessment, you've probably done this. And so we are asking students to identify which two objects on the right are just rotations of the one on the left, whereas the other two would be mirror reflections. Give you a second to see if you can figure it out. So the answer here is the first two are rotations of the one on the left, and the third and fourth are mirror images. I know this is also a little blurry, so don't feel too bad about yourself if you couldn't figure it out. It is very hard. We also give them a measure of cross-sectioning, because cross-sectioning is a spatial skill that has been found to be highly related to anatomical understanding, in which they are shown a figure at the top and then a plane going through that, and asked which of the responses is the one that you would see if you were looking at that plane. I'll give you a couple seconds here to also see if you can figure this one out. So here the answer is the third one. As you can see that where the plane is going through, that there's some differences in perspective. We also asked students about their spatial anxiety. So when you were doing the two questions beforehand, you might have gotten very stressed and very anxious about what I was asking you to do. And so here we have a bunch of questions that we ask students to choose the response that describes how much it would make them feel anxious if they were in this situation. So things that I just asked and how anxious that would make you feel would be an example of mental manipulation anxiety, but we also ask questions about imagery, so can you picture what outside looks like when it's snowing? Or navigation, can you tell me how to get home from here without a map? What are we hoping to find? So our goals are to take this information that we have on how students' ability is changing throughout participation in this master's program to see if we can better implement spatial training into the program itself to support these students in not only their master's program, but as they go into residency and into full practice. So let's look at some preliminary findings. So here is a measure of how we see at time 1, which is at their orientation, and then at time 2, which is 6 months into the program, their cross-sectioning ability has gone up. I know this looks very small. I promise you it is statistically significant, and it's very exciting because this is showing us that cross-sectioning is very important for this field, as we had theorized. Additionally, after these 6 months, mental manipulation anxiety has gone down, as well as overall anxiety, showing that these students are becoming more familiar with what they need to do to adjust things in their head and think about how they would be manipulating different types of objects in order to create a prosthetic or other devices. So what this means is that we see decreased anxiety and increased cross-sectioning ability, showing that participation alone in this program is very good for your spatial ability and decreasing anxiety, which means that we can take this information and include spatial training into the program, which would hopefully make people more confident in their ability in both this program and then, as I said, in residency and beyond, and hopefully provide better training for students in the future. That is all I have today. Thank you.